You hear the term machine learning thrown around all the time, but what does it actually mean? Well, in this explainer, we're going to pull back the curtain and demystify what it is, why it's so important, and, how it actually works, starting from the very beginning. Let's get right into it.
So let me start with a quick question for you. Think about your email's spam filter, the face recognition that unlocks your phone, or even how Google just magically finds exactly what you're looking for. I mean, on the surface, they seem like completely different pieces of tech, right? But believe it or not, they all share one incredibly powerful secret ingredient.
And there it is. That's the answer. They all learn from data. Instead of being programmed with a bunch of rigid step-by-step instructions, these systems are actually designed to learn and adapt just by chewing through huge numbers of examples. This is the absolute core idea of machine learning. To really wrap our heads around this, here's how we're going to tackle it. First, we'll talk about the problem that made machine learning so necessary in the first place. Then, we'll get into the whole new way of thinking that it represents. After that, we'll pop open the machine learning toolbox to see how it's actually done. And finally, we'll zoom out and look at the bigger picture. So let's dive into part one, the problem we face. The thing is, our world is generating an absolutely unbelievable amount of data every single second. And this data explosion created a whole new class of problems where the old way of programming, writing out explicit, fixed rules for everything, just couldn't keep up anymore. And this isn't just a small issue. This quote really gets to the heart of it. Smart data analysis, it's not just a nice to have anymore, it's a necessary ingredient for technological progress. The sheer scale of all this information demanded a smarter, way more adaptive way to build our software. I mean, just think about these challenges for a second. The source material calls them ill-defined problems, and that's the perfect description. How could you possibly write a fixed set of rules to rank every single web page on the entire internet? Or to recognize your friend's face in a dark photo versus a bright one? Or to catch spam when the spammers literally change their tactics every single day? It's basically impossible. You need a system that can learn on the fly. And this brings us right to our second section, a new way of thinking. This is the huge paradigm shift. Instead of a programmer trying to guess every single possibility and write a rule for it, we teach the computer by just showing it tons and tons of examples. This slide really nails the difference. On the left, you've got the old school way. A human has to sit down and define all the logic. But on the right, you have the machine learning approach. The program discovers its own logic by finding patterns in the data. So the intelligence isn't hard-coded anymore. It actually emerges from the examples. It's a total game changer. Let's make this super concrete. Say you want to build an automatic translator. The old way would be to hire a bunch of linguists to create this massive, exhaustive set of grammar rules. The machine learning way, you take something like the official records of the Canadian Parliament, which are published in both English and French, you feed millions of these already translated sentences to a machine, and you basically just tell it, hey, figure it out. The machine learns the subtle patterns of translation all on its own from these real-world examples. Okay, so we get the why and the what. Now for the fun part, the how. Welcome to the machine learning toolbox. So to make all this magic happen, we really need two key things. First, a way to turn messy reality into data the computer can actually use. We'll call those the ingredients. And second, we need algorithms to process that data. Those are our recipes. So here's a practical puzzle to get us started. Computers don't read English, right? They understand numbers. So if you want to build a spam filter, how in the world do you convert an email, just a block of text, into numbers a computer can work with? Well, one of the classic foundational techniques is called bag of words. It sounds a little silly, but it's actually a beautifully simple idea. You just create a master list, like a dictionary, of every single word you've ever seen. Then, for any email that comes in, you just count how many times each word from your master list appears. And just like that, the email is no longer text. It's a long list of numbers. And this table just brilliantly shows why that's so powerful. Because once you've counted the words across thousands of spam emails and thousands of normal emails, or ham as it's called, these patterns just leap out at you. Words like winner or Viagra are way more likely to be ingredients in a spam recipe. And words like meeting or report, much more likely to be in a legit one. The machine can now literally see these patterns in the numbers. So, we've got our ingredients all set. Our emails have been turned into numbers. Now we need that recipe. And in machine learning, the recipe is the algorithm. The algorithm's entire job is to look at the ingredients of a brand new, unseen email and make a decision. Is this spam or is it not? Here are a couple of really simple recipes to show you what I mean. The nearest neighbor algorithm is super intuitive. It's basically like saying, this new email looks a whole lot like that other email I already know is spam, so I'm just going to call this one spam too. Naive Bayes is a bit more mathematical. It looks at all the words in the new email and calculates the overall probability that it's spam, based on how often it has seen those words in spam messages before. Two different methods, but they're both trying to get to the same goal. All right, let's zoom out and try all these pieces together. We've talked about the problem, we've seen the big paradigm shift, and we've peeked inside the toolbox. So, why is this all so transformative? And what's the big picture for you? It really all boils down to these three key takeaways. Number one, machine learning steps in and excels where old-school, fixed rules just completely fail. Number two, its real power comes from learning patterns directly from the data. And number three, the secret sauce is always figuring out how to represent our messy reality, things like text or images, as clean, structured data that an algorithm can understand. And I want to leave you with one final, pretty important thought to chew on. We've established that these systems work by finding patterns in the data we feed them, and this process shapes everything from your search results to your social media feed. So the question to ask yourself is, what subtle, unseen patterns in all of our collective data are quietly shaping our world right now? Thanks for joining this explainer.